don't do river biogeochemistry
next
yet.
So the next generation.
So about
is
that's something we need to get in.
That was
What do you mean
River
because of
biogeochemistry.
dissolved organic?
That's 2 to 5 years of river biogeochemistry.
Okay, so that's a new one.
But what about agriculture?
That comes in land use change.
Well, so there's two. You can subdivide land use
yes
change
and no.
into the changes,
Yeah,
the change per se, and then the management of the land. That's typically how we do it.
Yes, life is so much easier. We are not directly involved.
We're involved with both the change and the management, so we're involved with both.
The changer and the change.
Okay, we should specify we're talking about agriculture as well.
I suppose you haven't discussed whether urban is included in the
Should be.
Urban, I don't think will be for a while, just because it's such a small area.
Well,
3%.
but its role is going
Perfect.
to increase
So
as the resolution increases, and as these, tiling
Heat islands.
approach.
Downscaling.
Yeah, if you're interested in impact,
just the
wouldn't-
tiling.
Yeah, the tiling can get
You know,
you
as
down
we go
to
to-
a few kilometers.
they already have that. I mean, some models already have urban tile.
Yes, exactly. Like
Yeah, but you wouldn't do that
Yeah,
to try
ours
to
is
do
gonna
climate
be-
simulations. You would do that.
No, it's a diagnostic thing. I mean, if you could imagine a situation where you said, well, why do we care about global warming temperature? It's weighted by the population density, and you don't care about the urban tile. Actually,
If we're running 1 degree atmospheric models for 1 degree land surface, and you do 8 tiles, that's like an 8
So,
Right.
degree.
Exactly.
I would.
so in terms of land use change, I mean, the way when we do
I
it,
got my ideas for the other time.
we sort of break it up into, agriculture, various crops, pasture, and forestry. Is that sort of how you guys think about it, or does those have different characteristics in terms of what it looks like, runoff, sort of thing?
yeah.
I mean, pasture is a grassland, but it's not a normal grassland.
Right,
It looks
it's managed
different.
Well, sure, we wouldn't typically specify it as a pasture, it would be a grassland.
We do because management typically.
I think this is actually an important question, which might come up later, which is that if we do have projections of land cover change for the future that are going to come out of these emission scenarios, they're going to mean a different thing for every different model. So I'm not going to just take his land cover change scenario and apply it directly to our model.
No, you'll have to
So some translations, which may or may not be trivial.
Yeah, sure, and it's down to the model to some extent to do that. But that's the way it is now. I mean, we get a land cover.
It's worse than that though, because they're not providing any except for one gridded land use products to go with the land use emissions that they're giving.
Yeah.
We used yours, but the same.
We do historically, but not forward. Only Image does it going forward. But of the 40 different ones
But
you saw there,
YASA now is starting to do that.
yeah, so it's just starting. In general, you can't. That's 2 to 5 year.
Yeah, it's in the 2 to 5 year.
Yeah, right, exactly.
But there is still the issues. Like when we use yours, we converted all the agricultural stuff to grassland. In our simplest type. Well, in our old model, we only had simple types. We only had 5 types. And it wasn't forest, and it wasn't
So you weren't
tundra, and
enough.
it wasn't
We
desert.
have separate models for sorghum and soybean.
No. We didn't have separate models for crops and pastures.
And I'm sure curious about managed forest. Do the models include forest cycling and stuff?
Yeah.
Forest regrowth cycles.
They do, yeah.
Well, there's a difference between the models that are run offline and the models that are actually in GCM. So
With
that's
this
one
one,
of the
but this one in particular.
routinely they don't, but they should. So it's a sort of 2 to 5 year time frame.
Right. So if we're talking core, then aren't we looking for something that everybody then does?
Or at least 5 or 6 of us will do.
Right.
Yeah.
So what's the 5 or 6 things that we can do now that weren't included in the 4th assessment? Just so we can get the core.
By not
Well, I guess-
included, you mean
Well,
not among
I guess
the
the thing is,
Like
what's the
ocean.
next? Well, the question is, it's actually pretty useful to look at this one. What's the next 6 months? In other words,
Well, I sort of see it as
it's
now
largely
as the
closing the carbon cycle. There
Sorry?
are models that close the carbon cycle with these limitations, but that's actually the thing that's doable because it's been done. They haven't become core, but they ought to do.
That's good. Well, actually, to me, these things, the 6 months, 2 years, and 5 years are all kind of artificial, since the next generation models from the modeling groups is for the next IPCC.
Yeah.
And they have to be done in 3 years.
So anything 2 to 5 is much.
5 years
It's all the
is
same.
beyond
All
AR5.
these scales are the same to me. It's 3
So why don't we
years.
just collapse to the next
Well, I
3
guess
years?
the way I look at it is what's
6 months is
what's
what's
doable
going on
now.
right
what's
Yeah.
doable by that 3-year time period.
What's going in right
and
now?
what's
is
going
the
to have
same
to
thing
go
that's
in
gonna
after that.
Yeah.
Well, I think I
That's
want,
that sort of thing.
so-
And I'm trying to just get it together.
Well, hopefully,
Well, the things that are doing, see what's going in 3 years is what's probably exists now
Right, and
at
that's
the edges of the community.
okay.
yeah, the state of the art sort of research
And that
things now.
community is what's going into the AOGCM.
supply
Yeah.
resources.
Right. So then I guess from when you were saying closed carbon cycle, then I hear that's also including the land water interactions.
Yeah, they typically do.
well, sort of what you presented in your talk.
So we can do that. I mean,
I think
Yeah,
another
look,
big one
that's
is going to be
groups.
this
There'll be
land
6 or
use,
so groups that do that.
land
There's
cover,
70
Anthropogenic land use change.
anthropogenic land use change. That'll be a big one. There's a global historical product anybody can have now. Every group I know of is working on
Starting to implement.
implementing that.
And those land, but okay, but then we get back to what those types were. Now is sort of the agriculture
It's going to start off crudely
The
as
pasture,
like crop
and then-
pasture, and then
and forest harvest.
forests, and then the age of recovering forest. That's going to be the first
yeah, and that's going to be
version.
that'll be fine.
And then you will see an explosion after that,
And
probably.
we're suggesting that's something we ought to be delivering for AR5, which means 3 years
Yeah.
to run sometime too. I think we should. I mean, I think if we don't do that,
Yeah.
then we've really failed.
Question.
Oh, perfect. I was just going to ask Michio. Rapid play of fast English.
Current seafoam models have ocean biology chemistry component, but somehow without biology.
Yeah.
And although I don't think that the details structure of ecosystem does not matter for the global carbon cycling, I don't think it's totally neglectable. Sorry.
Yeah.
And so my opinion is that all the models should have at least a simple biology in the ocean. So
And that should
In the
be done
core.
by this next time, right?
Yes.
yeah,
That's the
and
core.
it's-
I would agree.
I think
All right,
it's
so I
quite
got
simple,
3
and,
is simplified. it.
But this time
And,
it's not in the AR4.
not
Some-
all,
core.
not all.
Not
Not the
core.
core. Not the core.
Yeah,
This is
okay,
useful,
okay.
yeah.
This is great.
But it'll be in the AR5.
And
Yes.
although detailed ecosystem is not necessary in my opinion, what should be done is not model development, I think, and as Peter suggested, carbon feedback of the ocean about that feedback, model differences still significantly large.
Sure.
And
What
again,
feedback?
The
carbon feedback. I mean the
What's the carbon?
the negative feedback of ocean carbon uptake due to the increased atmospheric CO2. That is carbon feedback.
Now, is
More
that,
atmospheric
is that
CO2 more.
carbon biology, or are you talking about physical?
Physical.
Physical.
There is a
at least in my
biology
opinion.
element to it as well.
I was just which party was.
Okay, but
Yeah,
sure.
well, so I got
This
3 as
and,
simplified biology. Do we have a fourth component that's part of this?
No, that's part of the simplified
Okay.
biology.
This is the
Well, I think
solubility thing.
okay.
So
Again, we're going to have to. Go ahead.
Okay.
so the most important thing is before AR5 is not model development, but the identification of physical factor for the model difference in carbon feedback. First, this is the I'm the only Australian, so this is strongly biased opinion. Maybe.
Well,
but,
for that,
I think it's-
won't there be this sort of assessment? So the way that I guess some of this new IPCC stuff is, it's just assessing the literature. So won't there be that chapter when it assess the different carbon feedbacks?
but,
and,
Well, it depends how much of a CMIP, is there, what other
Yeah.
CMIPs will be between now and then, right? I mean, that's
Right.
pretty much it.
So
I would
are
argue
there-
there
there's a
won't be
separate
much
issue.
between now and then.
I think
So are there,
maybe
are there
this is
certain
some-
mechanisms then that you think ought to be part of the core
Short.
for the carbon then?
well,
out of the coal, what do you-
Well, you think, all right, so, we had the simplified biology,
yeah,
but it sounded like you were talking about more physical
yeah.
carbon, that there were certain factors that people wanted to include on that. Can we
they're
indicate
all
what those
included.
factors are?
I think
I
they're probably included.
don't know because what I mean is there are another activity
Yeah.
called OCMIP.
Yeah.
And that's another MIP for ocean only carbon cycle
Right.
modeling. And under under that activity, it was so detected that background background uptake of anthropogenic carbon has a significant model differences, and they saw that, but in my opinion, they have not. They hasn't investigated the cause for the model differences.
Differences. Okay, so
That is what is necessary.
A lot of it's on the physical side.
I think it's a
It's on
physical
gas
problem.
exchange rates and
No, it's just, actually, in my opinion, it's the Southern Ocean.
Southern Ocean
Yeah.
circulation.
is this tied up with the biology or no?
Okay. Well, no, not
No,
really.
the physical climate models do the Southern Ocean poorly, all by
I see.
themselves.
Oh, I see. So,
Unfortunately.
so even if you had the same ocean model, you get the most of
Yeah,
the range.
sure.
just
I mean,
with
that's
different
often the
That's
case with
what
these
I
couple of
think.
models.
That's what it looks like
Can
to
I?
me.
But
And
I
that
mean,
raises a great issue. Not to rain on everybody's parade, haha. But I'm rather concerned with all of these couplings in terms of the current level of error in the climate model. And it's great talking about all this coupling. We all love coupling, but to me, it's not just an issue of coupling, but with a level of accuracy within the climate model such that the coupled vegetation makes sense, so on and so forth. And
I mean, in other words,
Ron,
what
would you like to tell?
what
us
equivalents
when
of flux
errors are
correction
gonna
will have to
decrease?
be in the first? Will there have to be
It's
things
decreasing
equivalent to
slowly.
that in the first generation to make sure they don't get too off
well,
base?
I mean, this is
So-
something maybe we're going to talk about experimental design tomorrow, aren't we? And I think it should come through to this. We need to think about what would be the fallback position. I mean, basically, there's going to be a situation where half the GCM communities try this and it just doesn't work. And then are we going to say we would recommend you do this, or you just junk the thing? And then the second thing, which is related, is we need benchmarks, right? I mean, we need something that says that's good enough for you to run it forward.
Well, the physical climate side of the next one, of the core, will
Yeah.
probably be similar to what it was for this one.
Yeah.
Persistence is good forecasting. So, I think in terms of design, what we'll be asked to do tomorrow is design the core for the AR5 for the ESM part. Which means we'll have to define what an ESM is, which I'm not sure I
Is
know
that-
what it is.
So there's not new earth-shattering cloud parameterizations and things like that.
The filter of,
sure.
of the air model areas.
And that's why it takes.
That's why it's
it
important
takes
to
2
run
to
it.
5 years, because you actually got to tweak the darn thing when you put it
Right,
together.
and that's why it's important to run it.
In fact, at NCAR, we've already, the biogeochemistry group has already sent the atmosphere model group a list of metrics, which they think are important. It came out the other day, but
Must make you really
that's,
confident. Could you forward
well, I was not the one who sent it. Yes.
Yeah. Well, that's actually a very good filter.
Yeah.
Just happen.
Well, then we should write that down. I mean, in some ways, we need high-level diagnostics to give us an idea whether this is a trace or coupling, right? So we use
So, can
Kepping
reproduce
is
Kepping?
how we've been doing.
Yeah.
No, it's just it's a way to evaluate it, the dynamics. So
Yeah,
do a good
So,
job.
some of us Kepping.
it's C-O-1 now, isn't it?
Yeah.
Double P-E-M.
It's on the good skin.
Kepping.
C,
Actually,
Okay,
so
yeah, it doesn't know, just C-O-P-P-E-M.
Goes through all-
Classification. It's just a sort of
Yeah.
texture.
Like,
thing.
yeah, it's,
okay.
it's amazing.
I mean, the other thing you can do is to run your vegetation model offline, which is what we did, and say, okay, we run it with climatology, it does okay. Now we put in what we know the GCM has produced without vegetation. Have we got vegetation that's sensible? And you can do that test.
Yeah, we did that.
And you can do a sensitivity study and says, well, how big an area can we put up with, and then feedback.
And the other thing we did was put it in mid-layer model.
Yeah.
I think we're
do
straight.
double CO2.
Yeah.
But that's all tomorrow.
It's tomorrow's
Thursday's-
discussion.
Or Thursday's discussion.
Yeah, we'll note it down, though, because I think tomorrow we'll talk about today.
Yeah, this
Are there any more of these?
is it a showstopper?
We got it. Core, non-core now.
Well, I
in the
guess
future.
we haven't quite defined this the now the AR5 beyond AR5. That's sort of our categories, right? So have we gotten down to what AR5 may be?
AR5 core is what I think we should spend most of our time on, because the research end is going to be whatever.
Whatever.
And I think
it is.
I think on the land side, AR5 core.
Which is essentially what's nearing operation now, because
That's
you know,
correct.
that's
In the sort
By
yeah,
definition.
in the research sort of model, grade
Yes.
model. Yeah.
Right, the Vanguard model should
Right.
become the core model.
Yes.
Right.
This will have.
And what they have is they're going to have anthropogenic land use change.
Does that also include urbanization then too?
It can easily.
Where are they going to get that from? Anthropogenic
Well,
land.
that's what we're going to
the next
ask for.
question.
we'll get to that.
Okay, we've got 25 more minutes.
We also have
crop
tomorrow.
pasture,
Timber harvest.
wood harvest.
Well,
And I guess
Age structure in the forest.
Yeah, age structure.
well, vegetation dynamics.
And
And
simplistic vegetarian.
In some parts of vegetation.
With a small
Well, I
number
don't
of
think you can have
plant-
some part.
Yeah, because they're going to have a small
Well,
number of
but
plant
no.
functional types. You're going to have like
Yeah, sure, okay, but
2
I mean
or
that's
5
vegetation
or
dynamics.
7 or something. You're not going to have
Yeah.
80,000.
It's not going to have the real world. That's just another way of saying it's a model.
So without basically the drawing line, the nitrogen ozone fire, that's not
Fire,
AR4.
fire. I think we will
Fire
get
will
on a
have.
3-year time frame. I don't think nitrogen. We probably won't as a core.
Not as core. Research
Yeah.
as
Ozone not as
Yeah.
core.
Yeah.
I would
So
say
Vanguard.
Yeah.
And then so simple dynamic vegetation, really,
Yeah.
limited number
Yeah.
of types.
Limited number of types, but doing succession.
Instead of an infinite number.
Can I do such a good
Yeah.
job on the ocean biology?
When would we ever be doing
it?
No,
Ocean.
No.
I think on the.
that's what we were just talking about. I think we were talking about ocean, then we got distracted. You said one thing we need is this MIP.
Yeah.
But what about the components of the ocean carbon models now versus AR5?
AR5, right? So in my opinion, the current standard version is okay. For simple ones.
Just
Well,
NP and Z.
Yeah, maybe simply because that is what we have now. That because we do think so. We will keep on this keep this simple biology.
But don't you need like iron limitation?
Well,
could be, but
like this.
that can also be parameterized.
Okay.
So not necessary to a complicated ecosystem in the ocean.
So, I mean, I think the thing that we will have in the core models is simple prognostic biology. I mean, some of them are diagnostic now. They're basically restoring, kind of nutrient restoring things. So we'll have simple biology in all the models, I think.
NPZ sort of.
Yeah. And
At least.
yeah.
At least, yeah.
Okay, now
At least, yeah.
some of the models will then have more sophisticated, but not all of them. I think we've got to get to the stage where all of them have got some biology in.
That'll be the big difference. All
Yeah,
of
the
them
core
will have
models
some-
I think will have some biology in them. Like all the core models will have, I think, will have some vegetation dynamics. But they'll be like the more sophisticated models now rather than the next generation.
Yeah.
The spectrum level.
Yeah. Now, then at the 5-year time frame, I think we would be talking about things like iron limitations and
And coccolithofluorids, these.
yeah,
things.
okay, more sophisticated ocean ecosystem models.
How about the river biogeochemistry?
And I think river biogeochemistry is
That's
on
the
the vanguard of AR5. Yeah. I don't think that's going to be in the core.
You mean
Vanguard AR. It'll be the
carbon
research.
fluxes
No.
specifically?
I was thinking nitrogen.
Well, how about carbon? Well, maybe separate it.
Well,
How about
carbon's in there
river
though, too,
river
right?
carbon fluxes?
I mean, you're going to
Yeah,
look at
river
DOC,
carbon
DIC,
fluxes,
DOC.
I think, sure, I would say that that's on Vanguard's side.
Yeah.
I think we need to, some models have got to start looking at it, but I don't think it'll be in the
The
core.
carbon fluxes.
Well,
Yeah.
partly because when we go to talk about experimental design, having a net flux from ocean to land makes the spin up much more difficult.
Yeah.
And if you don't think it's going to change massively, you wouldn't do it for pragmatic reasons because it couples together your land and ocean carbon cycle spin ups, which is disaster.
Then don't do it. Spin up and do it.
Yeah, but you still have to get to some equilibrium
You have to
state.
get it, find your equilibrium.
You've got to get some state. So, yeah, I mean that's
Even,
one
even
I've got.
from the carbon, even if you just have the carbon.
Well,
coupling.
especially the carbon, because you'd have to make some. You'd spin up the ocean on its own. You'd have to make some assumption about
Yeah.
the net
Yeah.
source that was balanced.
Yeah.
You could do it
Yeah.
from observations, I suppose. I don't think it'll make very much difference, frankly, but someone needs to try.
And
That's-
another thing that I would like to address is the chemistry at the ocean bottom. And ocean bottom, yeah. And as long as we focus on the timescale 100 years also,
Yeah.
then it can be neglected. But if we go beyond 2100, so for example 23, 24, then it may be necessary.
What about the ocean bottom?
The resolution of calcite or
Carbonate dissolution. And actually, the simple models, the intermediate models.
If the time scale is about 1,000 years, it's definitely necessary, but 300 years, 400 years, kind of moderate and delicate time scale. So it may be
Well, that's
neglected,
interesting.
but
That means that should feed through. That's something that you would need for
Yeah.
stabilization experiments.
Yeah.
That you wouldn't need in transient.
For the long-term stabilization, not over 100 year, but if you're going.
Well, sure, but these stabilizations typically run out to 300 years maybe.
So it's a Vanguard or
Well, I think it's something we should note in point 3, which is that for very long timescales you need a new set of processes in the ocean models that are not currently in the GCM.
its inclusion itself is not very difficult technically.
Okay.
I guess, yeah, it's actually in our new one that we've got that, we predict that level of dissolution.
Okay. Could we go to question 2, do you think?
I think it'd be great. Do you have a pretty good tracking of question 1?
I think so.
I know, gave up on his computer.
I don't know, you've done that then.
Yeah, exactly. Yeah.
His battery ran
I
out.
think there's still my battery, but I think there's.
Mine's run out, so.
Well, we'll probably talk about this more tomorrow. But you're saying that the core is not. I think at NCAR we're not entirely sure how exactly we're going to have time to get our carbon cycle model going and integrate anthropogenic land use and veg dynamics part of the next IPCC. I know that's the goal, but there's definitely a lot of concern that with current resources that it'll be difficult.
But I think you'll do some version of that.
There will be a version of a carbon cycle
Yeah.
model. Okay. Yeah.
Right.
It may not have all
So-
those things. Yeah.
Or it may
That'll
have
be
them
that'll be
very
the goal.
simplistically or something.
Yeah. So, but
Yeah.
if that's I guess if NCAR will probably try to meet the community's core, right? But
We'll do the minimum.
we'll, yeah, we'll try to do as much as possible, which will probably be.
The veg dynamics actually doesn't place all that many additional constraints on experimental design or scenarios
No, that's right.
that aren't already there.
To work, right?
Yeah,
Yeah.
that aren't already there.
That's not
The
a
issue
constraint on
is,
scenarios.
No.
Yes, I think at NCAR is that there's a significant rewrite of our veg dynamics code because it doesn't mesh well, like we talked a bit about with the new carbon cycle code. So those are the kind of things that you get kind of scare people.
Yeah.
And I assume other groups have the same problem.
Oh yeah.
So
How about the synchronous asynchronous coupling and stuff,
Yeah. Question 2.
which is really the time scale for which
That-
you couple the physical.
And that's certainly much more relevant for the chemistry group.
Yeah, I could say in this group, isn't everything synchronous?
Well, you wouldn't update the veg dynamics every half an hour.
No.
Yeah, that's what I thought was an alternative that wasn't mentioned the other day. It's like it's all in the model, but it doesn't mean you're updating everything all the time. Right?
No, I mean,
Well,
you'd probably
so for the-
update it monthly, or we do it every
Yeah.
10 days. A month was fine. For veg dynamics. So solid
How
asynchronous.
often does your
which veg dynamics?
You guys are doing it,
I think-
I think,
Yeah,
two weekly. or
and the
something
land
like
use
that.
change you do,
Because
at most annually, if not.
Well, the main thing you're trying to do is get the phenology right.
Yeah, the phonology you might do daily actually.
We do daily, but
or something like that.
So the
we
time
do
scale.
PFT changes yearly.
Yeah, right, that's probably okay. That's probably okay. And LIFO index changes monthly, daily. Okay, I think so. Anyway, there's a nesting of timescales in the
Yeah,
book. So
there's
it's
a
going for
nesting of
fluxes
timescales,
every
yeah.
time
You're gonna
step,
do land use probably.
to phonology
yearly
every
or something.
day maybe,
Yeah.
and to veg dynamics
Yes.
every month or year. And that's just,
You know, because that's all built in already into these
yeah,
models.
Yeah.
sure. With the oceans,
Magic.
it's just a coupling timescale of the ocean model, isn't it? The physical coupling timescale is typically the same as the carbon timescale.
Oh, there, yeah.
So whatever it is, daily or something, is it these days?
The coupling,
Between land and ocean.
ours is
No,
2
sorry.
hours.
2 hours, really? Crikey. You must get some really interesting variability. People can surf.
No, the top box is 10 meters deep, so
Yeah, okay. Right, so
it's not going to change much in 2 hours.
so it's synchronous coupling anyway.
Yep.
For the ocean. Is there anything
But the ocean carbon fluxes, are those going to
They go across along with everything else.
Yeah.
I think we do our coupling every day.
The head CM3?
I think so.
Yes. I didn't know about head jam because they had talked about changing that.
Well, yeah, Julius Ling